Now I am going to start. First chapter is set theory, sets. Listen, students. The chapter is related to an SSLC. So already you know a little bit idea in sets. What is the definition of set? Set is a well-defined collection of objects we are filling. That is the definition. Well-defined means what? Well-defined means, suppose I will differentiate between the two examples. The one is a collection of all boys in your class. All the boys in the class. We can identify all the boys. We can separate it. All the boys. Person we can identify. A boy, girl, boys. That is the well-defined thing. That is called well-defined thing. Next, one more thing. The collection of all the most dangerous animals of the world. Dangerous animals of the world. Is it well-defined? Let us see. Well-defined or not means the animal, maybe suppose if you take a snake, it is a dangerous animal only. But some persons, it is a pet animal. Suppose if we take one more, some animal, suppose ox, suppose cat. This is the animals for some persons, or it is pet animals for some persons. That animals may be dangerous, they may have fear. That is not clear. That is not clear. That's why it is not well-defined thing. The set of all handsome boys in the class. Handsome. All the boys in the class we can pick. Handsome may be different to person. The set of the collection of all beautiful girls in the class. Beautiful, beauty will define person to person. So for some persons, somebody looks beautiful. For some persons, somebody are not beautiful. So that is clear. That is not well-defined thing. The well-defined is, in that case, that is not a set. Set means first of all it should be a well-defined thing. The well-defined means these two are the examples for well-defined. It should be clear. We can differentiate, we can identify, we can select. Such type of things are called well-defined cases. Otherwise, it is odd. It is we cannot guess. So person to person it will vary some things. That is not a well-defined thing. Okay, students. Come to the set definition. The objects set is a well-defined collection of objects. The collection of all boys in the class, it is a set. The collection of the dangerous animals, it is not a set. That is not a set. Okay, students. Like such type of examples I will give later. Next, the objects, elements and members of a set are the synonyms. Synonyms of the set. Objects of the set, members, elements, members. So the sets are usually denoted by the capital letters A, B, C, X, Y, Z, like that. Capital letters denoted by capital letters. Usually the inside elements of the set inside elements denoted by small letters, small a, b, c, small x, small y, small z, like that. Okay. Next, if a element A is belongs to the set A is in the set A, the element is in the set A. That we can say that A belongs to A, set A. Small a is the element, capital A is the set. The element small a belongs to the set capital A. In Greek, letter, the Greek symbol belongs to. This is called belongs to. Read as belongs to. A belongs to A. Suppose the element B is not an element in set A. Is not in the set A. We say that the element B does not belongs to set A. Does not belong. In notation, this is the form of the notation. Belongs to, does not belongs to, you can write like this. B does not belongs to A. Means the B is the element small letter, that is the element. A is the capital letter, that is the set. Okay, the element B does not belongs to set A. Means element B is not in the set A. Like that we are telling. Next, the two methods of representation of a set. Two methods of representation. Okay, friends, the method of representation. The two methods of representation of a set A. First method is roster or tabular form of a set. Roster form or tabular form of a set means how to represent this. In this form, the set is represented by this bracket, flower bracket. Okay. Then here one example. The set of all even positive integers that are less than 7 is 2, 4, 6. This method of representing the elements in between the elements separated by the commas, that are the elements or objects, members of the set. Different elements can be between the elements. We can write commas. Then all the elements corresponding to given condition, even positive integers condition. Then you can write 2, 4, 6 even numbers. Then you can close. You can begin with the bracket and close with the bracket. That is flower bracket representation. And one more example, the set of all natural numbers less than 10. Is all the natural numbers less than 10 only you can pick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that. All the natural numbers less than 10. All the natural numbers less than 5. Like that. The set of odd even integers or odd integers or set of even integers. Like that, all the examples. That is set of prime numbers, like that, students. Okay, you can represent in this form, that is called according to the condition. You can write the objects or elements. Condition and elements. You can write. That method of representation of the set is called roster or tabular form. Next, the second method is set builder form. Set builder form. They will give the one set. Then you can build. You can form a set builder form. Means you can form the set. Means all elements. That means in this process they will give one set of elements. But in that case, all the elements in that set satisfy the common property. That's important. All the elements in that set satisfy the one common property. Possess, that is, all the elements possesses a single common property. That's very important. For example, A, E, I, O, U. By seeing this, we can decide very clearly A, E, I, O are the vowels in English alphabet. If they give the like this, that is the roster form or tabular form they will give. You can convert. You can write like this. These are what? The vowels in the English alphabet. That how to express in set builder form means. Suppose A is a set. A is a set. We can express. How to express means set of means the flower bracket can read as set of X such that the dots, these dots we can read as such that, student, such that set of X such that. What is X? X, that X is represent all the elements in that set that possess a single common property. What is that? Set of X such that X is a vowel in English alphabet. X is a vowel. Means we can get from this X such that X is a vowel means what is vowels? A, E, I, O, U are the vowels. We can differentiate. We can write A, comma, E, comma, I, comma, O, comma. This is called set builder form. Two methods. Two methods, roster form or tabular form. One more is set builder form. Two the methods that are that. Okay, students. Now coming to the exercise 1. First exercise I am studying. The first exercise, the first problem is verify whether the following things are set or not a set. Justify your answer. Okay, the first one is the collection of all the months of a year beginning with the letter Z. It's very clear. We can identify the collection of all the months in the year beginning with the letter J. With J letter, what are the months will come? January and June and July, like that. That's how. Okay. January, June and July. Jan, June, June. Okay. This is a set. We can collecting with easy manner. There is no any problem for defining. This is called well defined thing only. So it is a set. This is a set. Next one, the collection of 10 most talented writers of India. 10 most talented writers of India. Very clear. 10 most talented writers means in which stream talent means in which stream, in which in mathematics or physics, science or in any biography or like that. In where the collection of 10 most talented writers in India. Talented writers. It is not a talented, most talented writers. It is not a well-defined thing. It is not well-defined thing. So it is not a set, students. Is it clear? Most talented means it is vary from person to person. One person may know talent. One person is talented in mathematics. One person is talented in science. It is varies from talent from person to person. So it is not well-defined thing. We cannot collect here. How if this sentence, if you modify, it becomes a set. How it is means that the talented writers in particular stream means then it becomes a set, like that, not a set. So now the given thing is not a set. A team of 11 best cricket batsman of the world. Best cricket batsman. You can give one name, Kohli, somebody, Dhoni, somebody, like that, or Gale, like that they will give, okay, names. So, for one person, it is also varying from person to person. One person may like Kohli, another person may like Dhoni, another person may like Pollard, or one more person may like Gale, like that. It is very difficult to identify. It is varying from person to person. It is not a well-defined thing. 11 best cricket batsman. 11 only they are saying. It's not well-defined thing. Hence, it is not a set, students. You should identify. You should don't confuse between well-defined and not well-defined. Both what are defined, well-defined, and what are not well-defined. It should be clear. Okay, students. Just check. Okay, students, you see the next problem. It says, let A is a set given 1, 2, 3, 4, 5, 6. And some points, some problems they given whether that element or object, that number belongs to that set or does not belong to that set. Very simple, students. Whether it is in that set, you can write that symbol belongs to. Whether it is not in that set, you write does not belongs to. As coming to the points, friends, here 5 is there. 5 is in the given set, so it belongs to the set A. Okay, students. 8. Where is 8? There is no 8. Okay. So here you can put does not belongs to the set A. Here 0, students. 0. Where is 0, students? There is no 0 here. So does not belongs to the set A. That's all. 4, students. As 4 is there. Yeah. It belongs to the set A. 2. Next. 2 is there, students. 2 belongs to the set A. The last element is given 10. Here 10 they given. Very clear. There is not 10. So you put the symbol does not belongs to set A. Next. Write the roster form. Roster form of the following problems. First of all, A is set x is such that x is an integer and it lies between -3 to 7. -3 to 7. Okay, in between integers. What are the integers? In between -2, -1, 0, 1, 2, 3, 4, 5, 6. That are the integers. -2, -1, 0, 1, 2, 3, 4, 5, 6. Also, this also can be expressed as -2 is there, +2 is there. Right? Plus or -2, plus or -1, 0. -2 plus 2, plus or -2. -1 plus 1, plus or -1, 0. 1, 2, 3. 1, 2, 3, 4, 5, 6. Like that we write. Okay. What is x is an integer and lies between -3 to 7. All the integers in between -3 to 7. X is a natural number less than 6. 6 less than 6 natural numbers begin from 1, 2, 3, 4, 5. 6 less than 6 they are asking. Up to 5 it will come. Next, coming to the next problem. X is such that x is 2-digit natural number, friends. 2-digit natural number such that sum of digits 8. Natural numbers and its 2-digit natural number. That is 2-digit natural number. Natural numbers begin from 1 onwards. That 2-digit natural numbers and whose sum of digits is 8. It should be 8. For example, 0, 8 if we take, friends. 0 plus 8. 8. The 2 digits if you add you will get 8. 1, 7 if you take, friends. 1 plus 7, 8. 2 plus 6, 8. 3 plus 5, 8. 4 plus 4, 8. There was 5 plus 3, 6 plus 2, 7 plus 1, 8 plus 0. The last one is 8 plus 0 is 8 only, students. Like it. So then the result is the final answer in the set form is 0, 8 means 8. 17, 26, 35, 44, 53, 62, 71, 80. Very clear. All these are natural numbers only. Is it correct? Yes. Next, coming to the D problem. D is set of x such that x is a prime number which is divisor of 60. It's 2 points, students. Its conditions satisfy the 2 things. One is the prime number. Another one is divisor of 60. Prime number, divisor of 60. First of all, divisor of 60. 60 divisors. 1 and itself are the divisors. 2 is the divisor. 2 into 30. 3 is the divisor. 3 into 20. 4 is the divisor. 5 is a divisor, 6 is a divisor, 7, 8, 9, 10 is a divisor, 11, 12 is a divisor, 13, 14, 15 is a divisor. Why? Because 15 4s are 60. Okay, friends? Like that. So, in this, friends, in this prime number should be there. 1 is not a prime number, 60 is not a prime number, 2 is prime number, 3 is prime number, 4 is not prime number, 5 is prime number. This is not prime, this is not prime, this is not prime, this is also not prime. Hence, you will get the answer 2, 3, 5 only. 2, 3, 5 only. You should check two conditions to satisfy. One is prime number, another one is multiple divisor of 60. Divisor of 60, all are there. Divisors of 60. 60 is the divisor, 4 is the divisor of 60. But 4 is not prime. You should not write in that set. Like that. The set of all letters in the word trigonometry. Trigonometry. In that word, all the letters are there. In that word, letters you make it a set representation from T. Here T is there. One time you write enough. T. Need not write 2 times. One time. R. Here R is there. One time only write. I. Only one I. Z. Yes. O. 2 O's are there. One O you write. N. M. E. Y. Like that. The final thing is, need not write repeated letters. Repeated objects in the set need not write. Okay. T. R. I. Z. O. N. M. E. Y. Like that, similarly, one more thing, better, B-E-T-T-E-R, better. In that, the better has B-E-T-R, better. B is 1, is, 2 E's are there, 2 T's are there, 1 T, right, 1 R is there, just write 1 R student. That's all. B-E-T-R, B-E-T-R, like that. Okay, students, this is set builder form. Next, coming to write the following sets in set builder form. Set builder form. Set builder form. First one, X 3, 6, 9, 12. They given 3, 6, 9, 12. One common property is there. What is that common property? Let us see, students. 3 into 1, 3 into 2, 3 into 3, 3 into 4. The common property is 3 multiples, 3n to 4. How I am writing in set builder form? You see, students, set of x such that x is equal to 3n. N is a natural number, and 1 is less than or is equal to n less than or is equal to 4. 1, 2, 3, 4. Maximum 4 n value. Why? Because here you see 3 into 1, 3, 3 into 2, 3 into 3, 3 into 4, like that. Maximum 4. So the condition how I am writing 1 less than or is equal to n less than or is equal to 4. Where is that n? X is equal to 3n. That n is x is equal to 3n. Like that. Second problem. 2, 4, 8, 16, 32. They give it. Okay. 2. You can write 2 to the power of 1. 4. You can write 2 square. 8. You can write 2 cube. 16, you can write 2 to the power of 4. 32, you can write 2 to the power of 5. 2 to the power of 5. 32, 2 to the power of 5. Very simple if you observe it. So, the power is varying 1, 2, 3, 4, 5 like that. The power is varying. The base is same. 2 power, 2 power, 2 to the power of like that it is there. So, the set of x such that x is equal to 2 to the power of n. N is a natural number and n lies between 1 to 5. 1 is the minimum, the maximum is 5. Understand, students? Very simple. The technique is here. The set builder form means all the elements in set satisfies a single common property. That is the trick. 2 to the power of n is the trick. Next, third one. Coming to this 5, 25, 225, 625. What else? Set of x such that x is equal to 5 to the power of n, student. 5 to the power of n means 5 I am writing 5 to the power of 1, 25, 5 square, 25, 5 square, 125, 5 cube, 625, 5 to the power of 4 students. 5 to the power of 4. So here 5 power, 5 power, 5 power, 5 power it is there. So you can write here 5 to the power of n. Here the maximum power n value is 1, 2, 3, 4. 1 to 4. The maximum power value 1 to 4. Like that. Here 2, 4, 6 and so on. X such that x is an even natural number. Like that it is coming. You see students? 2, 4, 6 are even numbers. Students. Even numbers. These all are even numbers. Even number general form multiple of 2. 2 into 1, 2 into 2, 2 into 3. That is the 2 into n. N is a natural number. X is an even number. That is called even number. 2, 4, 6 are all even numbers. So the set builder form how you are expressing is set of x such that x is an even natural number. That's all. Coming to the next problem. 1 is 1 square. 4 is 2 square. 9 is 3 square. And so on. 100 is 10 square, students. 100 is 10 square. All the powers are 2, 2, 2, 2 only. The denominators means not denominators, the base. Base value is 1 square, 2 square, 3 square, 10 square. The base is 1 square, 2 square, 3 square, 10 square. Maximum 10, 1 to 10 in between. So set of x such that x is equal to n square. N is a natural number and that natural number is n square. N is a natural number. That natural number n value lies between 1, 2, 3, 4, 5, 6, 10. Up to 10. Maximum is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maximum 10. Why? Because 1 square is 1, 2 square is 4, 3 square is 9. Like that, students. 10 square is 100. Just take all these very simple set theory problems, sets problems very simple.